I'm Angela Yapis from Group 25. For our project for B1500, we chose on this data set climate change Earth surface temperature data. We only used one of the files in there, but all four of the files combined was 100,000 points. But the one we used only had 20,000 entries, including like date. So here it is. So I have everything loaded already, but you just look at it. Some of them don't have entries. But for year 1850 and up, they have entries. The data goes from 1750 to 2015. So we just wanted to see like whether, like if like the months, the average temperature for each month was getting hotter from 1750 to 2015. And we chose this because it's just because it met the requirement. And we found it on kaggle.com, and all the files are .csv. So I'll get to the charts in a second, but let me just run the script. So script first, it will convert this dt variable into y, m, and d. So this is year, month, and date, and then it will prompt the user to enter in a value for user input for two different user input years, and then it will find when the user input when y equals the user input. And then if you enter in like incorrect value, it'll prompt the user to enter in another value, but like with more specific range. So let's enter in like 1700 and input second year to compare. So we'll enter in 15. So enter in a year between 1750, and this is for the first year, so we'll enter in 1850. So a menu will pop up, and then so the menu will keep popping up. Like you can click any of these variables: max temperature, minimum temperature, average temperature, for input year one until you hit N, and then that will get rid of the menu. So you can see like this was like max temperature, I guess. So month number year one. If this is to plot a point on these two graphs for both input years. And if you enter in something that's not within range, like 1 to 12, it will prompt the user to enter it again. So enter 0 or 13, 15. It'll just keep going until user enters in something between 1 and 12. So I'll enter in 2 this time. Same thing for year 2. And it'll plot it. So month number to plot over average temperature over the years. So from 1750 to 2015. So I'll just press 3. Here's all of our graphs loaded, and I'll go over them. So here's the graph month over years. So this is for 3, fluctuates. The lowest is like 2 degrees or less than 2, like 1.5 to like 7.8. So everything ran. We were about here in our script. And if you enter any incorrect month number for that too, it will prompt the user to enter in another number in between 1 to 12. So then it finds, so it plots that, and then it finds the mean for average year for input year 1, and then input year 2, and then standard deviation for both input years. So for our first script, it takes the averages, maximum, minimum from both input years and converts it to Fahrenheit. So here is our first function, sorry. And the inputs, and the outputs, average, maximum, minimum, both input years in Fahrenheit. So then you'll go to our next script, and that'll take the averages that we got, the outputs for both input years, maximums for both input years, minimums for both input years, and it will find a new average for both input years using the maximum and minimum temperatures. So you do that, finds the overall average too for that each input year, and then it creates a bar graph. So the bar graph is here. So input year 1, input year 2, both converted. And you can like see the differences between input year 1, which was 1850, and input year 2, which is 2015. 1850, 2015. Looks a bit higher. All right, so let's close out of that. Sorry. So let's get to our next function, which is the it compares the so it finds the difference between input year 1 and input year 2, calculated average, the data average, just converted to Fahrenheit. So it's just from the data and then converted to Fahrenheit. Sorry, it's not like the new calculated one that we just did. Function 2. This is from function 1. And then it finds a difference and counts up the number of days when the difference is less than 0 of input year 1 minus input year 2. And then if it's above 0. So go scroll up a bit. Says that months input year 2 is hotter. Months input year 2 is hotter is 12. Okay, so input year 2 is 2015, so 2015 is hotter than input year 1. So next goes to our curve fitting function. So it just plots the input year 1, and then it finds a best fit for that, and it's a 4th-degree polynomial. Here are the coefficients. After that, the script creates a table that you can compare the new temperature and the data temperature. So this is calculated with the maximum and minimum temperatures in Fahrenheit. This is just from the data converted to Fahrenheit, both input years. There's another table for the overall average for input year 1 in Fahrenheit, overall average for input year 2 in Fahrenheit. So this is 1850, this is 2015, this is hotter, as you can see. Just check really quick. Yep, that's right. Input year 1, 1850. So here's our third table. So you can see the data uncertainty for each month from the data. Here's our calculated difference. This was used this was calculated using a 95% confidence interval using standard deviation and mean for I guess the data set from 1750 to 2015. So this would be like plus minus that from the average. So it's a confidence interval. And this is just the difference between our calculated values. So here's for both input years. And you can see like, so this is like 3, right? And if you go back up for the month of January, go back up to table 2, you can see our calculated average temperature from the minimum maximum is like 36, and then the data temperature was like 33. So it's actually like 3 degrees higher in Fahrenheit. So here's all of our graphs. I closed out of one. That was just a bar graph displaying the 2 temperatures. And so this is just like temperature in Celsius, new temperature, the calculated temperature with the new from like with the minimum maximum in Fahrenheit. And then this is months over a month over years from 1750 to 2015. This is a curve fitting, and then the other one was a bar graph comparing the 2 input years. So in conclusion, we learned about from this project was that was really helpful was I guess like the like while loops. We had to use like nested while loops, um, and then to get the user to input something between a range of like 1 to 12, and then we had to use like just a while loop. So while it's less than 5 and 5 is equal to m, and it'll just keep popping up the menu. And yeah, we did the same thing for like a lot of the inputs, and then we used if else for like our third function and the for loop for our third function because we wanted to compare the difference between each value in array. And thought like what was really helpful with this project was learning how to like find positions of like a specific year, I guess, for the data, and then finding the averages of a specific year or the maximum temperatures of a specific year, just like finding using the find command. All right, that's about it. Thank you.